Consider the differential equation dy dx is equal to 4 minus y over 10, where y is equal to 2 and x is equal to 0. Use Euler's method with step size 0.1 to find an approximation for y when x is equal to 0.5. Give your answers correct to 4 significant figures. Okay, so let's do part A first. For part A, we're going to be using the recursive formula. So what we're going to start with is yn is equal to yn minus 1, so the previous term, plus 0.1, since that's our step size, times 4 minus yn minus 1 over 10, right? So we took this, but we chose the previous y instead of the current y. All right, so now I'm going to write all this down. We're going to have n here, and then we're going to have xn here and yn here, and we're going to do the calculations. And it said to do them to 4 significant figures where needed. So let's have n be 0, 1, 2, 3, 4, and 5, and then we're going to fill in this table. So let's start with xn. That's going to be 0, then 0.1, then 0.2, then 0.3, then 0.4, then 0.5. Actually, let's move that up a little bit, because that's the step size is 0.1, and then we need to find yn. So the first yn is going to be 2. Then we're going to use that in order to continue on. So here for this one, we're going to plug in yn is 2, right? So for y of 1, we're going to say, well, what's the previous term? It was y of 0, which is 2. So 2 plus 0.1 times 4 minus 2 over 10. And that is going to be equal to 2 plus 0.1 times 1/5, which 1/5 is going to be, we can just write it like that. That's probably fine. And then that's going to be 2.02. So the answer for this one is 2.02. And now we do the same thing again for y2, except now we would have 2.02 plus 0.1 times 4 minus 2.02 now over 10. And then we need to figure out what that is. That's going to be 2.0398. Then we're going to do the same thing for all the rest of these as well in order to figure it out. So if we do the same thing for n is equal to 3, we're going to get 2.05940. If we do the same thing for 4, we get 2.07880. And then if we do the same thing for 5, 2.09801, and continuing. So if we go back to here, they would like it for up to x is equaling 0.5. So what they would like here is y5, right? y5 is equal to approximately 2.09801. And there we go.